So, equivalent circuit. We got to find the equivalent resistance, and then we got to find the current. So the way you find the equivalent resistance is by doing the resistance for series, which is R1 plus R2 plus R whatever, and by doing R parallel, which is 1 over that, equals 1 over R1 plus 1 over R2 plus whatever else I have. That's how you find equivalent resistance, and equivalent current is very easy. It's V equals IR. So here's the circuit I have. Okay. So I look at this and say, okay, one is in series, right? Because it goes right from the battery into R1. R2 looks like it's probably in series, right? It goes right from R1, I guess. And then R3 looks like that one's in parallel, maybe. It splits and it goes this way. So if that's the case, I would say R equals 1 plus 2, since those are series, plus 1 over 3, since that's parallel. And then I would solve and get a number. And of course, if you did that, you would be wrong. Don't do it. Okay, you're all going to make this mistake at least once. Okay, so we did it now, so you got it out of the way. Now you've all made the mistake. Okay, you're all going to want to do this. You're going to want to just say, okay, this is series, this is parallel, add them up. Here's how you do series, here's how you do. That's not going to work. What you have to do is you have to combine the series things together, and you have to combine the parallel things together, and then you have to do it again and again and again and again. Now, it's not going to be like the last chapter where you had those problems that went on forever. These will be much smaller, but it is that kind of a thing where you do step 1, and then you try step 2, and then you just keep going from there. All right, let's go ahead and let's take a look at what's going on. If I'm a little choo-choo train, I go from here, I go through the first light bulb, I get to this point. At this point, I can choose what Mr. B Choo-Choo wants to do. It can either go this way to the light bulb, or to the battery, sorry, or it could go this way. So, how do I know if I do series or parallel? If you use the word and, it's series. If you use the word or, it's parallel. I go through R1 and I go through R2 or R3. Okay, that means R2 and R3 are parallel, but R1 is series with them both. See how I have to go through R1 to get through either R2 or 3? But I don't have to go through R2 and R3. I go through one of them. So, how do I set this up? I always start as far away from the battery as I can, and I work my way back. So I'm going to just combine only these two here. And I'm going to call this A. So I say to myself, okay, how do I find A? Well, A is parallel. So I say 1 over RA is not quite lunch yet. Good. 1 over RA equals 1 over R2, which is 2. Can you move it down? Yes, I can. Thanks. Plus 1 over R3. Again, I'm going to go ahead and keep things in fractions. You can turn them into decimals if you want, but I'd suggest fractions. In order to get a common denominator, the common denominator is going to be 6. So multiply this by 3 over 3 gives me 3 over 6. Multiply this by 2 over 2 gives me 2 over 6. Add them up. That gives me 5 over 6. But I don't want 1 over RA. I want just RA. So RA equals 6/5 or 1.2. These are ohms for resistances. So up here in my drawing, I'm going to write A equals 6 over 5. Okay, now I'm going to redraw the circuit. I'm going to draw the circuit again, but instead of having R1 plus R2 plus R3, I'm going to redraw it with A. So my new circuit is going to look like this. Battery, 3 volts, connected to R1, which is 1 amp, 1 ohm. But I connected these two into A. So instead of having 2 separate ones, I'm going to have one. Yep. I'm going to have one with the value RA. And that value for RA is 6/5, or we'll just call it 1.2. And now it's very obvious what this is. This is a series circuit. Absolutely, it can't be anything else. I go from the battery, I go through that resistor, I go through this resistor, I go back to the battery. It's the only path I have, so it's series. So now all I have to do is say REQ for the whole thing is R1, which is 1, plus RA, which is 1.2, get my answer of 2.2 ohms. Yes, sir?
Where did you get the RE?
So I'm solving for equivalent resistance for the whole circuit. So REQ, I asked myself, for the whole circuit, is it parallel or series? When I redrew it, including A, it's series for the whole thing. So that's why I just added those two numbers together. Okay? All right. We'll do the last part when we come back. We'll do part B when we come back. This is part A taken care of. All we have to do now is find the equivalent current, and that is actually very easy. So we'll do that when we come back from lunch. And then we'll work on practice 1 and practice 2. So Ryan, you can just work on practice 1 and practice 2.
I already turned the practice 1 in.
Okay, so you're all done with that one?
Yeah.
Perfect. So just work on practice 2. And all you have to do for the second part, the part we didn't get to here, is just use V equals IR. So V is the 3 volts, I is, or R is 2.2. And so on. See you when you come back. So we found the equivalent resistance. We found the resistance for part of it. We called that A. We found that to be 6/5 or 1.2. We then combined that in series with R1 to get 2.2 ohms, or it'd be 11/5 if we're keeping it in a fraction. So now we're ready for the last bit, which is find the equivalent current. And the equivalent current is just going to be V equals IR. So V equals IR. My voltage is given as 3. I is what I'm solving for. My resistance is given, it's 11/5. You can go ahead and leave that as 11/5 if you want, or you can leave it as 2.2. Divide both sides by 2.2 to get I by itself. Or you can do it as a fraction, either way.
Yeah, fractions are way easier.
Yep. So 3 divided by 2.2. It's going to give you a big nasty thing, which would be 1.36 repeating. Yep. So if you leave it as a fraction, you would end up multiplying both sides by 5/11, and it would give you 15/11s. I honestly don't care which way you go, fractions or decimals. I'll have the answers both ways, so whichever way you do it. Generally, if it's a multiple choice question, I'll leave it as fractions. But on problems that you're just solving out, I don't care which way you do them for me. Either way will be fine.